Good morning all. This is Mrs. Harshika working as an assistant professor in AA and DS department. Today I am going to discuss the subject code AL3451, subject name Machine Learning in Regulation 2020. What is machine learning? Machine learning is a branch of artificial intelligence that enables computer to learn from the data and improve their performance automatically without being explicitly programmed for every task. For simple definition, a computer learns patterns from data and use those patterns to make decisions or predictions. Here, experience denoted as a E and task denoted as T and the performance measures is a P. Finally, the experience E is measured by P. For example, email spam detection is the task identifying emails as a spam or not spam. Here, experience E is large set of previously labeled data, performance P, accuracy of classification, that is the identifying the spam or spam email or not. And some of real-time examples: house price predictions, salary predictions, diabetic predictions, loan approval predictions, image classification. Before a machine can learn, it needs some key elements. Some of them: data set. Data set is a collection of data for given problem. Features: measure property or characteristics of the data. Label: each and every data is labeled data to identify, to get best prediction. Model: mathematical representation which is learned from data. Algorithm: it is used to train the model. Training set: the portion of data, max usually 80% used to teach the model. Test data: data the model has never seen, used to evaluate how well it performs. Performance measure: finally measure the performance based on accuracy, prediction, recall. MSE is a mean square error. Review of linear algebra for machine learning. This topic from the mathematical and conceptual foundation for understanding how machine learning algorithm actually work. Why linear algebra for machine learning? Linear algebra is extremely important in machine learning because almost all data is represented mathematically using vectors and matrix. For example, students data set. Row represents the students and column represents the features like marks, attendance, age, etc. Linear algebra helps us process data efficiently, performance transformation, detect patterns, train models faster. Role of linear algebra. Linear algebra simplifies complex tasks such as data transformation, dimensionality reduction, optimization accuracy. These are all the main tasks for linear algebra. In machine learning, we mainly deal with three basic elements: scalars, vectors, and matrices. Scalars are single numeric values. Vectors is a list of numbers representing a data point. Matrices, collection of vectors arranged in rows and columns. It is used to store full data set. Next topic is introduction and motivation for machine learning. Machine learning is a technique that allows computers to learn from data, identifying pattern, make decision and predict outcomes. Most importantly, we do not explicitly program rules. The machine learns rules automatically from data. Machine learning learns patterns automatically by analyzing many spam and non-spam emails. So, machine learning replaces rule-based programming with data-driven learning. Next, why do we need machine learning? Traditional programming fails when problems are too complex, too large, too dynamic. Machine learning is needed because it can learn from examples, improve automatically, handle complex patterns, work with huge data. Solving complex business problems. Traditional programming struggles with tasks like image recognition, natural language programming, and medical diagnosis. Machine learning, however, thrives by learning from examples and making prediction without relying on predefined rules. Handling large volumes of data. Next, why importance of data in machine learning? Data is the fuel of machine learning. Without data, model cannot learn, model cannot predict, model cannot improve. Good data must be accurate, diverse, representative, clean, better data, better model performance. Better data, better model performance. Role of training and validation testing data. We divide data into three parts: training data, validation data, and testing data. Training data is used to teach the model, validation data is used to tune parameters, testing data is used to check real performance. This ensures the model works well on unseen data, not just memorized data. Finally, summary. So today we learned linear algebra is the mathematical backbone of machine learning. Vectors and matrices represents data. Machine learning allows computers to learn from data instead of rules. Data quality directly affects model accuracy. Machine learning equal to machine mathematics plus data plus algorithm. Thank you.